What is up, good people? This is section 4.4, dividing polynomials. And so we've been spending the past couple of days, couple of lessons, adding, subtracting, multiplying polynomials, figuring out what is a polynomial and what is not. And today we're going to start talking about how to divide them. And it's a little tricky, so we're going to spend 2 days doing it. There's polynomial long division, and then there's another way to do it as well. We'll learn in the next lesson. But just to review, this is what division looks like with just normal numbers. You can remember these are the three examples of the way you would divide, and this is what it would look like when you're doing long division. You notice there's a lot of carrying down. There's remainders. You do it one number at a time, and we're going to do very similar things here. You can see as a preview, this is what it'll look like down here. Just as a reminder, this is what the vocabulary would be. So you have got a dividend, and then you divide it by a divisor, and the answer is a quotient, and you might have a remainder. If the divisor is just going to be a monomial like 3y, then you can just divide each of the terms in the numerator by that 3y. So you get 15y cubed divided by 3y is 5y squared. 6y squared divided by 3y is 2y. And 3y divided by 3y is 1. 4f to the fifth divided by 4f squared would be, 4 divided by 4 is 1, and f to the fifth divided by f squared would be f cubed. And then you bring the subtraction down, and then 6 divided by 4 is 3 halves. F to the fourth divided by f squared, you do the subtraction, you get f squared. 12f to the third divided by 4f squared is 3f. And subtraction, and then 8 divided by 4 is 2, and f squared divided by f squared is is 1, because 2 minus 2 is 0, so that's just the degree of 0. And you can see here, even when you have multiple variables, it's going to be very similar. 6 divided by 3 is 2, j squared divided by j is just 1j, and k divided by k is 1. Subtraction, 9 divided by 3 is 3, j divided by j is 1, and k squared divided by k is k, because the exponents 2 minus 1 is 1. Here, 4a squared times h squared divided by 2a squared would be 2h squared, because 4 divided by 2 is 2. The a squared divided by a squared is 1, and h squared divided by nothing is just h squared, or divided by 1 is h squared. And then subtraction, and we get 8 divided by 4 is 2. 8 divided by 2 is 4. A cubed divided by a squared is 8a, because 3 minus 2 is 1. And then h divided by h is also 1. Then we have 3 divided by 2 is 3 halves. A to the fourth minus a divided by a squared. You have to do the subtraction to figure out the new exponent here, and I'll let you do that. So here we're going to take, and now that we know how to divide a monomial by a monomial, we're going to do the exact same thing here, repeatedly over and over again. And so before we move on, I just wanted to say that as an audio check, my favorite concert that I've ever been to was a festival in Florida for the New Year's Eve 2000. It was 1999, December 31st. And there was a big 3-day-long festival, and the very first thing I did for the New Year 2000 was watch my favorite band at the time, Fish, perform from midnight, January 1st, 2000, from midnight clear through sunrise. It was awesome. It was a 7-hour-long concert, and it was just a great way to kick off the millennium. So here we go. Speaking of kicking off, let's kick off this polynomial long division. What you have to do is, the sequencing is so difficult, or not difficult, it's difficult, is so tricky that I've decided to uncover it bit by bit as I talk so you can see what's going on. So the first thing you do is you ask yourself, x cubed divided by x is going to be x squared. And there it is. X squared. And then you have to multiply both the terms here in the divisor by x squared. So x squared times x is x cubed. And then x squared times minus 2 is going to be minus 2x squared. Now, you remember here in the when you do it with just regular numbers, the next thing you have to do is subtract. 2 times 4 is 8, so 8 minus 8 is 0. Well, the polynomial long division right here, you have to subtract as well. And the thing about the subtraction is that, especially when you can see here, one of these terms is addition and one of these terms is subtraction. So from a studentship point of view, it's much more reliable to change both signs and actually add them together. So if you're going to go to, if the next thing mathematically would be required to be subtract, what I recommend doing is changing their signs and then adding. And because there's so many signs getting thrown around all over the place, what you really got to do, what I recommend, is that you actually write both signs down, the original sign and then the sign you need to change, so that you're very clear of exactly which one is which. So, by design, x cubed minus x cubed is going to give you nothing, and then, x cubed plus a negative x cubed is going to give you nothing. So then, negative 3x squared plus a positive 2x squared is going to give you negative x squared. If you remember with polynomial long division, the next thing you have to do in this case would be to bring down the 7, and that's exactly what we're going to do here. We're going to bring down the minus 10x. And now we're going to repeat the process. We're going to ask ourselves, what is negative x cubed divided by x? And the answer, of course, is minus x. And then you have to multiply this times both of the terms. We're going to get minus x times x is minus x squared. Minus x times minus 2 is positive 2x. And now we need to subtract them. But really, from a studentship point of view, much more reliable to change the signs and add them. And now, so what you're going to do, because just because it's just more reliable from a studentship point of view, make sure you circle the new signs that you've changed them to. And so now we're going to add minus x squared, or negative x squared plus positive x squared. By design, they cancel out. You should get nothing here, always. But this minus 10x and this negative 2x, you're going to add them together, and you're going to get negative 12x. Bring down the 24, and then, again, we're going to ask ourselves, negative 12x divided by x, what is that? Well, it's minus 12. And so minus 12 times x is going to give you minus 12x, or negative 12x, and then minus 12 times minus 2 is going to give you plus 24. And then in order to, then we need to subtract them, but of course from a studentship point of view, it's much more reliable to change the signs and add. And you can see both of them cancel out, and you get left with nothing. So the remainder here is 0. The reason we knew we got to the remainder point was because there was nothing left to bring down, and also this is a minus 12 over here. All right, so let's try this again. Here, 2x squared divided by x gives you 2x. And then you multiply 2x times x to give you 2x squared, and then 2x times minus 1 to give you minus 2x. We need to subtract them, but it's much more reliable to add from a studentship point of view. So let's change the signs and then add. When you add them, 2x squared plus negative 2x squared gives you nothing. They cancel out by design, and then 3x plus 2x is 5x. We're going to bring down the 4, and then we're going to ask ourselves 5x divided by x is just 5, and then 5 times x is 5x, and 5 times minus 1 is minus 5. We need to subtract them, but in order to reliably do that, we're going to change the signs and add. We get left with 9 when we add them together. And we can tell that this is going to be a remainder because there's nothing left over. There's nothing left to bring down. We've already brought down the 4, and then we're also left with a 5 here at the top. So that we can just say the remainder is 9. Let's do it again. So x to the 4th divided by x is x cubed, and then x cubed times x is x to the 4th, and x cubed times minus 7 is minus 7x. And let's see, we're going to change the signs when we go to add, and when we add them together, we get negative 3x cubed. Bringing down the 27x squared looks like that, and then we have to ask ourselves, negative 3x cubed divided by x is going to be minus 3x squared. Minus 3x squared times x is negative 3x cubed, and minus 3x squared times minus 7 is plus 21x squared. We're going to change the signs in order to add them. And when we add them, the negative 3x cubed and the positive 3x cubed cancel out. And we chose it that way. So then the plus 27x squared plus negative 21x squared is going to give you 6x squared. Next thing we have to do is bring down the minus 46x, and we ask ourselves 6x squared divided by x, what is that? It's going to be plus 6x. 6x times x is 6x squared, and 6x times negative 7 is minus 42x. We need to subtract them, but in order to do that, it's more reliable to change the signs and add. So minus 46x and plus 42x gives you negative 4x. We're going to bring down the 28 here, and then we have to do the division. Negative 4x divided by x will give you a negative minus 4. And minus 4 times x gives you negative 4x. Minus 4 times minus 7 gives you plus 28. We need to subtract them. In order to subtract them, we have to change the signs and add. And notice everything cancels out, which is great because there's no remainder. There it is. Next, let's do this. We got 2 more in us, and then we're done. So, as a first step, it's kind of one thing I notice is that here there's x cubed minus 12x squared, and then there's no linear term. It just goes straight to the constant term minus 42. And I think at some point what you have to do is you have to, as you can see right here, you have to insert what's called a placeholder. A placeholder is, just like if you were dividing 105 by 5, you couldn't just write the 105 as 1 and 5. You need a placeholder, 0 for the tens column. And in the same exact way, you need a placeholder here. Because so much of polynomial long division works only because you're really organized and you've got the quartic term, cubic term, quadratic term, linear term, constant term, 4, 3, 2, 1, 0, and exponents all, or degrees all in order, even in the right columns. So what you really have to do is make sure that the columns are preserved. It should go 3, 2, 1, 0 as the degrees. So we're just going to write, maybe I'll do it a bit later, we're just going to write a 0x right here, as you can see right here. And that'll be my placeholder to make sure all the columns get in nice rows. Because if they're not organized and neat and nice rows, then, nice columns, then things get messy and ugly and difficult. And oftentimes incorrect. So let's start off. X cubed divided by x is x squared, and then x squared times x is x cubed. X squared times minus 3 is minus 3x squared. We need to subtract. In order to do that, we have to change the signs and add. When we do that, the x cubed and the negative x cubed cancel, but the minus 12x squared and the plus 3x squared gives you a negative 9x squared. Negative 9x squared divided by x is going to be, there's the placeholder. And which of course we need to break down. Negative 9x squared divided by x gives you minus 9x, and then minus 9x times x, of course, is negative 9x squared. Minus 9x times minus 3 gives you plus 27x. We need to subtract. In order to do that, we're going to change the signs and add. And then the negative 9x squared and the plus 9x squared cancel out, and you're left, and then also the 0x plus negative 27x gives you negative 27x. We're going to bring down the minus 42, and then negative 27x divided by x is just negative 27. Negative 27 times x is negative 27x, and negative 27 times minus 3 gives you plus 81. We need to subtract. In order to do that, we change the signs and add. The negative 27x and the plus 27x cancel, and the minus 42 and the negative 81 add up to a negative 123. And I can tell this is going to be a remainder because there's nothing left to bring down. We've already brought down the last, minus 42, and also we've also found the constant term right here, which is minus 27. So it's going to be a remainder of negative 123. Last one. Here it's going to be a little trickier because we've got 3 terms over here. We've got a quadratic. In the divisor, we have a quadratic, we have a linear, and a constant. But the process is going to be very similar. Notice I've already found my placeholder. It's going to be plus 0x. The problem was originally written 6x cubed plus 5x squared minus 7. And if you're going to start if you have a cubic term, you have to write a cubic, quadratic, linear. Here, like if you were dividing 6,507 divided by 321, you couldn't just write the 6,507 as a 657. You would need to write 6507 to indicate that this is thousands, hundreds, tens, and ones. So same thing here with to the third power, squared power, first power, and the degree of 0. Let's do this. So we got 6x cubed divided by 3x squared. When you do that, you get 2x. 2x times 3x squared is positive 6x cubed, and we have to do this 3 times now. 2x times each one of these 3 terms. 2x times minus 2x gives you minus 4x squared. 2x times minus 1 gives you minus 2x. Change all 3 signs because we need to subtract, and we get, and then the 6x cubed and negative 6x cubed cancel out. You add the 5x squared, and you add the plus 4x squared, and you get plus 9x squared. Then 0x plus 2x gives you 2x, and you bring down the minus 7. Then you have to ask yourself, what is 9x squared divided by 3x squared? That's just 3, because 3 times 3x squared gives you 9x squared. And then 3 times minus 2x is going to give you minus 6x. 3 times minus 1 gives you minus 3. We need to subtract all of them. And in order to do that, we change all 3 signs, and the 9x squared and the negative 9x squared cancel out by design. That's what we chose. We got the 2x, and then the plus 6x gives you 8x, and the minus 7 and the plus 3 give you minus 4, which is going to be the remainder. Notice there's nothing left to bring down, and we've already found the constant term. So it's going to be a remainder of 8x minus 4. Yes, you can have an x in the remainder. All right, some important habits I'm going to leave you with. First, check for placeholders. That's the very first thing you should always do in each one. Maybe I didn't role model that very well, but you can see that's what you've got to do, because you couldn't. If you bring this minus 7 over into this column, it's going to be a little disastrous. Second, group columns by like terms. So you can see this is the x, underneath this bar, this is the x cubic column, squared column all the way down, linear column all the way down, constant term all the way down. You see some examples even follow that even further by making sure they put the 2x over here as well, but we didn't do that today. Write out all the signs and circling the new ones that allow you to add. And so you can see that, as I've done here, just much more reliable to do the addition. So in order to do that, you've got to change all the signs. And in order to do that, you've got to make sure you keep track of which one is the old sign, which one is the new sign. So circle the ones that allow you to add. That's all, y'all. Take care, and I'll see you in class.